Find the inverse of the 3 by 3 matrix 4, 2, 2, 0, 3, 1, 2, 0, 1, provided it exists. So let's start by making an augmented matrix with this in the left-hand side and the identity in the right. We need to do row operations now to make this left-hand side look like the identity matrix. A starting point would be to attempt to get zeros in these two entries here. One of them has already been taken care of. And I might point out that since 2 goes into 4 easier than 4 goes into 2, I could swap the first and second rows before I do any more row operations. So let's do that first. We get the new matrix here. Now to get a 0 in this entry, we could scale the first row through by a -2 and add it to the bottom row. If we multiply by a -2, we would have -2, 0, -4, 0, -2, 0, 0, -2. And we could add these rows together to get a new bottom row of 0, 2, 0, 1, 0, -2, with the other two rows unchanged. Next, let's try to get zeros in these two positions here and here. Since we already have a 0 on the top, we only need to get a 0 in the bottom. However, neither one of the second and third rows goes into the other well, so I'm going to scale these two rows. I'll scale the second row through by a 2 and the third row through by a -3. And that will make their leading terms match. This is going to give us, when we scale the second row through by a 2, a 0, 6, 2, 0, 2, 0, and the third row a 0, -6, 0, -3, 0, +6, with the top row unchanged. Now we can add the second and third rows together. When we do that, we're going to get 0, 0, 2, -3, 2, 6. The second row we can scale back down to get 0, 3, 1, 0, 1, 0, which was the original second row, and the top row remains unchanged. Next, let's try to get zeros in these two positions here. We could do that by scaling each of these two rows with -2s and then adding the bottom row to them. If we do that, we would have for the top row -4, 0, -2, 0, 0, -2. For the middle row, 0, -6, -2, 0, -2, 0, and the third row remains unchanged. Now let's add that third row to the other two. Adding the third row to the first row would get us a -4, 0, 0, -3, 2, and -2 + 6, or 4. If we add the third row to the second row, we would have a 0, -6, 0, -3, -2 + 2 is 0, and 6 + 0 is 6. And the third row remains unchanged. Now all we need to do is scale each one of these rows. The top by a -1/4, the middle row by a -1/6, and the last by 1/2. And we'll have an identity matrix. We're going to need some spare room, so let's erase our previous work. Okay, here we go. If we scale that top row through by a -1/4, we would have 1, 0, 0, 3/4, -2/4, and -4/4. If we scale the middle row through by a -1/6, we have 0, 1, 0, -3/6, 0, -6/6. And if we scale the last row through by a half, we would have 0, 0, 1, -3/2, 2/2, 6/2. So that means our inverse matrix, let's just call it A inverse, is the matrix on the right-hand side here. And if we clean that up, we would have 3/4, -1/2, -1, 1/2, 0, -1, -3/2, 1, and 3 as our inverse. And so there's our answer.